Good morning or good evening, depending on where you're following this conference from. The work that we are going to present is about conceptual modeling in product design within virtual reality environments. My name is Marcello Lorusso, and in the context of this research, I've been working with the engineer Marco Rossoni and Professor Giorgio Colombo from Politecnico di Milano. So the main goal of our study is to investigate the main reasons behind the mismatch between the quick technological development of immersive application and user experiences and the relatively scarce adoption as a design tool. So speaking about how this presentation is going to be organized, firstly we will focus our attention on the state-of-the-art of these technologies, providing a number of definitions and methods of classification according to which the most relevant studies in this domain have been later categorized. And afterwards, a discussion on the state of the art will be carried out, mostly focusing on the most common criticalities that emerge when comparing and trying to put into context the studies analyzed. On this basis, we selected some of the most evolved methodologies and figured out the necessity to build up a defined protocol to test them in a rigorous way. Based on a first group of people involved in the testing session, we will try to outline the first evidences and suggest the future research directions. So the very first simple question that is worthy of attention is the following. What is conceptual design? There are several definitions available in the literature, but for the purpose of this study, we will consider the one by Pal and Bates, according to which conceptual design is the initial stage of the development process when the principal solution is determined. Now, conceptual design applies to a large range of subdomains across various engineering fields, and it usually unfolds in different forms depending on this. For example, a management engineer might find effective to use diagrams to quickly sketch up the layout of a production plant, whereas a mechanical or energy engineer would use schematic representation of a given system, whereas a product designer tends to rely on artistic sketches to provide visual information about the identity of a product that is strongly influenced by aesthetic consideration as well. The latter subdomain of the three is the one we want to focus on, and with reference to it, we have found that digitalization has proved extremely beneficial for the embodiment and detailed design stages when rigorous representation are needed. But it hasn't developed quite as effectively in relation to the conceptual design stage, where analogic tools are still much preferred. For example, when considering a typical surface modeling environment such as Alias by Autodesk, there's a number of criticalities that the designers have to face. Firstly, working with standard 2D input devices while displaying the 3D environment on a flat panel creates a critical obstacle at interaction level. A natural interaction system to shape the resulting 3D model is not possible, and to overcome the limitation of such UXs, a cognitive approach to provide the inputs is the only way possible. On the other hand, bidimensional representations, being them on paper or digital, cannot be seamlessly translated into 3D models that have to be built manually from the ground up by specialized professionals. This is where virtual reality comes in, meaning that immersive user experiences can restore inside a virtual environment more natural interaction and visualization systems, elevating the technology from an inspection or validation tool to an actual design tool to be used from the very beginning of the development process. In this short video, a recently developed software called Gravity Sketch is shown. We will later discuss it more in depth. So in this way, visualization and interaction is much improved, and not only that, also perceptual motor skills of the user can be translated into natural gesture to shape the 3D geometries, rather than relying on providing rigidly determined inputs through specific commands. Now, shifting our attention to the state-of-the-art of these applications, we found out that several researches have been carried out in the past 10 to 15 years to investigate new innovative ways to take advantages of this rising technology. We decided to categorize them based on two types of parameters, namely the input method and the digital representation of the geometry. Under the Input Methods class, we classify the applications based on the hardware systems implemented as interaction tools. Some rely on standalone devices like controllers or sticks. Others are based on hand-tracking devices like data gloves or bare-hand recognition systems. The other class regards the geometry representation, meaning the digital structure of the data that are translated into 3D geometry. On one hand, we have those applications with a parametric approach, often resembling the workflow of traditional CAD applications. Others rely on mesh-based representations, meaning that the models do not have an embedded semantic or specific geometry features, but are shown as simple polygonal entities. In this slide, we can have a quick overview of the most significant studies that we've mentioned among the ones with the parametric approach. As said earlier, we have the ones that adopt traditional VR controllers or remote-like devices. Then the ones based on sticks or wand-like devices. Next, wearables. And finally, bare-hand detection systems. In a similar fashion as before, these are the most relevant mesh-based applications that we have found in literature. We first have the ones based on traditional controllers, then sticks or wands. We couldn't find anything relevant among the wearables. And finally, some based on bare-hand detection. So after carrying out this collection of works, a few criticalities emerged, so a further investigation is needed. Firstly, given the novelty of the technology in terms of both hardware and software, an established methodology to combine in an effective way the two things has not been determined yet. With reference to tests and assessment methods, there's not a unified paradigm to understand the real potential of the proposed solutions. Then, most applications show a relatively rough state of development. And finally, and this is very much related to the previous point, it's the fact that in terms of demonstration of the application's capabilities, we often see very basic geometries that have little significance towards a real-world design context. This is why we decided to set up a testing session to analyze the best VR solutions available today to the public after setting the benchmark with a short session based on traditional 2D sketching. We gave to each tester a desktop mouse and we asked them to memorize its shape and to reproduce it both with analog tools, namely a pencil and a sheet of paper, and with digital VR tools in a randomized order, trying to recognize the most defining lines. Speaking about the VR tools, we had to rely on specific hardware, meaning a commercial head-mounted display system connected to a workstation PC, a pair of VR controllers, and a PC display onto which it is possible to see the user point of view in real time. And finally, also a sufficiently large room to operate freely in the virtual environment, as shown here by my colleague Marco. Digital 3D sketching has been one of the two candidate solutions based on VR that we analyzed. As mentioned before, Gravity Sketch is the name of the application. In this case, the user produces weightless digital strokes in an empty virtual space, in which no dimensional references are provided. The other methodology is based on 3D sculpting, meaning that the user is now trying to sculpt a digital 3D object while replicating the activity of clay modeling. That is a very recurrent technique in the real context scenario of product development. The name of the application tested is Codon VR. Since it is not possible to provide with standard VR controllers an effective sense of touch, this is replaced with haptic vibrations occurring when the user interacts with the 3D shape. So here we describe how the test had been structured in detail. After a short questionnaire to gather information about the educational and professional background of the users involved, we gave them the possibility to train and get acquainted with the VR tools, explaining the basics of the UXs. Then we let the user observe the mouse for a few minutes and ask them to sketch it or sculpt it with no time limitations. Then we proposed another questionnaire after testing each methodology, and finally we proposed an assessment questionnaire to gather more general feedbacks about their experiences with these new tools. Based on this first group of testers, some preliminary results can be still considered valuable. It must be said though that due to the pandemic we could not conduct the test with a large enough sample of users to reach a level of statistical significance. But in the next few slides we can appreciate some of the works by our testers. In particular, we compared the most faithful sketches with the least accurate ones for each methodologies, starting with 2D sketching, then this is 3D VR sketching, and finally 3D VR sculpting. A thorough observation of these few images still allows us to propose a few qualitative considerations at least. Number one, VR tools by themselves do not empower the single user with dramatically improved drawing skills. In other words, the only user coming from a product design educational background showed better results across all three methodologies compared to the other testers coming from mechanical engineering. A second aspect is related to the fact that, in the testers' opinion, 3D sketching seemed to be the most enjoyable of the VR methodologies, since strokes were in general much easier to manage compared to the simulated solid models of 3D sculpting. In particular, users complained about the lack of an effective tactile feedback system that would be crucial to gather a finer control over the inputs. Also, the matter of physical stress after prolonged session is a problem to take into account. An important consideration to evaluate the results is the fact that because the skills of each user tend to vary across a very wide range, the comparison of each methodology has to be normalized based on the outputs of the single user, considering how or she behaved with each system and not on an absolute scale. Now, speaking about future research directions, the next aspect that will be further developed regards the matter of the reliability of the metrics when trying to evaluate the results of these testing sessions in an objective way. This is still an open question that indicates the future direction of the study. Until now, many researchers consider time to accomplish a given set of tasks as a reliable metric. This kind of assessment isn't really in the goals of our own study, since we let the tester draw freely without any external pressure. The quality of a drawing or a model is something much more difficult to assess because it's much harder to define quality in the first place. So, perspective, media, light or line weight were the parameters that have been most often used in the past. But in the end, there was always a certain margin of subjectivity even in those cases. Plus, the novelty of this specific technology means that established metrics have not been proposed yet. And this in fact is the goal we strive to in the next developments of this study, that is trying to come up with more objective assessment methods to figure out the real potential of such systems. So, in conclusion, after a first part providing an overview about the state of the art in relation to the use of VR as a design tool, we can make some interesting considerations. So, So far, the real potential of the technology towards real context scenarios is not clear yet. We claim that one of the possibilities to tackle the issue is to understand in a rigorous way how to test a new application based on a specific protocol that we have tried to set up. The goal is to understand where are the true capabilities of these new tools and understand if and where they can be truly beneficial. And finally, the matter of how to assess the results is still an open question, since objective metrics haven't been proposed yet, but future development of the study will definitely take them into account. Thank you for the attention.